Hello, everyone. So let us continue our discussion. So in the previous class, we introduced ourselves to infrared spectroscopy and its usefulness in determining the functional group present in a molecule. And we looked at the infrared spectrum, which is composed of two axes. The x-axis composed of the wave numbers or the frequency of the infrared region, and the y-axis correspond to the percentage transmission. That means if the molecule is absorbing, so according to that, that particular peak would be transmitted through the molecule. So that is recorded in that peak that you see in the infrared spectrum. Okay, so now in today's section, well, let us look into the two regions that you find in the infrared spectrum. One of the region that you find is the functional group region. Okay, and the second region that you find in the infrared spectrum is your fingerprint region. So as I introduced to you in the previous class, the infrared spectrum is actually ranging from 4,000 centimeter inverse to approximately 600 centimeter inverse. Now, we can divide it into two parts. One part is extending from 4,000 centimeter inverse to approximately 1,400 centimeter inverse. So that means up till here. Okay, so this is 1,400. So one part of the spectrum is this one, which is extending from 4,000 to 1,400. And the second part is extending from your 1,400 centimeter inverse to approximately 600 centimeter inverse. So this is the way you divide the infrared spectrum into two regions. And this region from 4,000 centimeter inverse to 1,400 centimeter inverse is given the name of the functional group. I'm writing it in short because of some internet problems. There is a delay that is happening in the writing segment. So I'm sorry, extremely sorry for this particular inconvenience. So we have a functional group region, okay, which is the first part, that is 4,000 to 1,400 centimeter inverse. The second part is your fingerprint region. So I am representing fingerprint as Fn. Okay, so you have a functional group region, and then another region is your fingerprint region. Okay, so as the name itself suggests, that all the stretching vibrations that you see for each of the functional groups will be coming or will be recorded in the functional group region of the infrared spectrum. And rest of this fingerprint region that falls in the 1,400 to 600 centimeter inverse, they actually can be considered to be same as a fingerprint of each individual. Okay, as you know that every one of us has a fingerprint, and that is unique to an individual. You cannot have two different people with the same fingerprint. In the same way, uh, even though we have two isomers of a molecule which has same set of functional group, still the fingerprint region will be pretty different for each of the molecules. So that you can easily see from this picture. This molecule is your 2-pentanol. This is 2-pentanol, and this is 3-pentanol. Okay, this molecule is 3-pentanol. So these are isomeric. They are functional group, not functional group. They are positional isomers. So in one of the molecules, the position is 2. In other molecules, the position is 3. So what happens here is, when you look at these two molecules, the functional group that is present is basically your OH group. Both of them has this particular functional group. So as you can see, the functional group region has since both of them contain the functional group OH, they have a similar functional group peak for them. Okay. Similarly, these are basically the CH vibrations that are present in this molecule. So that is also similar. That's why these two peaks are similar in both these isomers. Okay. But if you look at the fingerprint region that is extending from 1,400 to 600, you can easily identify that both these isomers differ in their fingerprint region. Like If you just look at the functional group region, you might think that these are two compounds are same. But when you look at the fingerprint region, they are pretty different from each other. So actually, these fingerprint region denote basically what is called the molecular framework of the molecule. So basic framework changes in the molecule is easily recognizable in the in this fingerprint region. So it is a very characteristic of each molecule. So when we have a library of various compounds, their fingerprint regions are usually recorded. So whenever you isolate certain products from natural um, natural elements, and when you compare it with already recorded library, you can easily recognize whether those compounds are already reported or it's a new compound. So that is a very handy tool. That's why fingerprint region is also important to us. But as a organic chemist, okay, for me, the most important thing that I use IR spectrum is to determine the functional group present in the molecule, because most of the time, the molecular framework of the molecule is, I use other techniques like mass spectrometer or NMR. NMR is very powerful in determining the molecular framework of the molecule. And also, to some extent, if you have conjugated molecule, you will use UV visible spectrum to determine the molecular framework of the molecules. So as an organic chemist, and since this topic comes under the organic chemistry, we will be focusing only on the functional group region of the spectrum. Though when you go for higher studies and research work, at that time, when you go for material research, at that time, material people look more, and inorganic people, they look more into the fingerprint region as well to determine the intricacies, because most of the time the materials that you're dealing in inorganic chemistry, they are insoluble in organic compounds. So usually it's very difficult to determine the functional group regions. So that is why they stick to the determination of this fingerprint regions, and to determine the exact molecular framework or the various frequencies that are associated with their particular compound. So here, this is a particular table. So before going into this particular thing, I told you vibrations that are present in the molecule are basically two types. One is the stretching vibrations, and another one is a bending kind of vibration. So if I ask you a question like which should be having more higher frequency to vibrate, will it be stretching or is it bending? So it's very easy to say for all of you that stretching vibrations will be having higher frequency. That means you require higher energy to stretch a vibration than to bend at a bond angle. So bending vibrations are usually at a very lower frequency, and stretching vibrations are usually at a very higher frequency. So usually the bending vibrations comes in your fingerprint region, and the stretching vibrations are the one which are actually coming in the functional group region of the infrared spectrum. And that is why most of the time what you are measuring in infrared spectrum as an organic chemist would be the stretching vibrations that are present in the functional group region. So this particular table that you see here, for each type of bond, you have a characteristic region in the functional group where you will see a peak. Okay. For example, just now we looked into this particular functional group, that is the CO functional group. As you can see, it comes near to this 17, it comes under around the 1700 centimeter inverse. And as you can see, it's a very strong peak. And you remember when we looked into the previous video of one of the compound, the peak corresponding to CO bond was pretty strong peak. Okay. And then we also looked in that particular spectrum, the OH bond, and I told you the OH peaks usually fall in the range of 3400 centimeter inverse. So this is the region where you will usually find the OH. There will be slight variation in the value, but it will fall near to, like CO will falling near to 1700, and this would be, OH would be falling around 3400. up or below, but it would be not too much too much variation, but it would be very a short range. And usually, as you remember from the spectrum, it was a very strong peak, and also that peak was a little bit broad. It's not a sharp peak. So this table, all of you, please write it down in your notebook and um, try to make a table of it and stick on your wall so that you get familiarized with the different types of bond and their region in the functional group region of the infrared spectrum. This is very important because when we are going to use it for analyzing the compounds and the presence of functional group, you should be pretty much able to easily find out what functional groups are present on the basis of the peaks that you see in the infrared spectrum. So that is why I say, please write it down in your own handwriting and paste it on the table where you are studying, so that whenever you are solving any problem, you look very handy to you to see that value and recognize the functional group present in the molecule. So I hope you had a good basic understanding of the infrared spectroscopy and its application in a slight sense to the determination of functional groups in the molecule. We'll go into more details in the coming video. Thank you very much for your attention and have a nice day.